here we go. Hopefully the audio is better this time. Hi, also, welcome. We're gonna get started here in a couple seconds. I have my hot chocolate ready. I'm gonna light my candle. Then we're gonna get going. All right, candle is lit. It's official. Cool. Welcome. We're gonna code today. Well, we're gonna read more about coding. I don't know that they'll actually be coding per se for a little while yet. Just because it's gonna take a minute to get through the introductions, but we're gonna keep diving into it. So that last page was exactly where we left off in the first part, so we're gonna continue with motivation and mindset. Get ready to listen to me reading a whole bunch more. I did want to say also I made an error in the last part. I have read aloud since middle school, obviously. I did a multi-part series on some Proust, so I felt bad. I felt like I had lied to you and wanted to amend that. So I am still rusty though. We're gonna take it together. Okay, motivation and mindset. So our introduction, learning to code is incredibly rewarding, but it can also be difficult and frustrating. They keep hammering that point home. Like any skill worth knowing, it takes time to acquire, and it can't be learned in a weekend or even a month. With that said, we believe anyone can learn how to program as long as they are willing to put in time and effort. So before we get into the meat of the curriculum, we're going to go over the following to help you get the most out of the Odin project. The things that will help you succeed in your goal of learning to code, and the pitfalls that you should try to avoid. Take a moment to think about why you decided to learn programming. Do you want to have a fulfilling career that pays well? That'd be nice. Are you excited by the creative outlet programming provides? Yes, I am. Are you determined to develop the skills and abilities to build any app you could think of? I'm super excited. I have some things that I'm already thinking of. Do you want to start your own company by turning an app idea into reality? Maybe. Seems a bit far out, but I could give it a try. Your motivation could be a combination of these reasons or something else entirely. Well, mine is a combination because I said yes to a bunch of the different ones. Whatever it is, hold on tight to your motivation. This will be what pulls you through to the end of this journey, giving you a definite goal to aim towards. To give you a motivation a bit of a boost, you can read one of the successes of others in our Discord, Odin Success Stories channel. So I'm going to skip that for now because we have not yet logged into Discord. That might be a little tricky, but we're going to come up to it later. All right, mindset growth. Growth mindset. I had those backwards there. Okay. Your mindset is very important when teaching yourself any new skill, not just programming. Your mindset will have more of an impact on your chances of success than just about anything else. Someone with a fixed mindset believes if they don't get something on their first attempt, they never will. They believe they simply aren't smart enough to be able to do or understand some things. However, there is a wide body of research that showing that intelligence is not fixed but can instead be developed. Someone with growth mindset believes they can get better at anything with effort and persistence. What does this mean for you? It means you can learn new skills and develop new talents with persistence and grit. There will be many times throughout Odin Project that you will get stuck on a concept or programming problem and may find yourself questioning your ability to learn programming. When you find yourself in this position, remind yourself that you may not get it yet, but with persistence and grit, you will. Struggling with something is growth. It doesn't matter how long you struggle with a concept or project. All that matters is that you have the grit and tenacity to see it through. That's how real learning happens. While you're working through the curriculum, embrace the struggles you encounter with difficult concepts and complex projects. Be sure to celebrate your persistence at overcoming these struggles. When you find yourself questioning your abilities, reflect on the successes you have already achieved while learning to program, the projects you have completed, and the concepts you once didn't understand but do now. This is all the proof you need that you can do it. You can do it. I'm going to skip the, okay, we'll look at this one. You can learn anything. Oh, it's Khan Academy. Okay. The learning process. Learning concepts and then practicing them will help you to more fully understand how things work and fit together. Projects are the ultimate method for ensuring that your theoretical understanding aligns with how the programming concepts and techniques actually operate. When learning, your mind will constantly switch between focus mode and diffuse mode. Focus modes occur when you are consciously focusing on learning, reading, watching videos, or working on a project. Diffuse mode occurs subconsciously at times when you are not actively learning, such as when you're doing the dishes, exercising, or sleeping. In this state, your mind goes about the business of connecting what you have been learning to the other things you know. This is where breakthroughs happen. So just a note on this, I can totally attest to this. I had a short career as a professional dancer, and I would be in rehearsal and be consciously trying to memorize material, dance material. I would be like, okay, following along with the choreographer, trying to memorize the material. It would feel like I couldn't keep it all in my brain or in my body. And then when I always had to like go and have a good sleep, and then I could come back the next day and it was just like in there. I always had just a really hard time like connecting to the material the day of. Like sometimes it would happen. Obviously you'd have that one choreographer or that one like collaborator that you really connect with, but like stepping away from whatever problem or whatever thing I was trying to learn and then taking the time to rest, like having a good sleep, I could come back the next day and just like be right on it. So personal experience with this one. It's important to know that your mind goes through these two states when learning, because you can utilize this to make your learning more efficient. When stuck on a concept or problem, taking a break to refresh and let your subconscious work on making connections more often than not yields a solution to your problem. The trick is to put effort into solving the problem first and then take a break. In short, understand it, practice it, and finally teach it. Teaching what you know is another great way to solidify what you have learned and can often reveal holes in your knowledge that you wouldn't have identified otherwise. You can practice this method of learning by helping others in our community. Learn how to on Coursera, and then Ruby Rogues have a podcast on how to learn. I like podcasts. We'll open that one up for later. Again, personal experience with this one, I think that teaching is the best way to learn actually, because it really shows you your own understanding of the problem and how many different ways that you can come at a solution. Like teaching a simple concept of like it's not simple, but I'll use like atomic structure. I was a tutor. I was almost a tutor. They gave me the wrong address, so I never ended up being able to find the place. But like describing atomic structure to someone, you can do it all sorts of different ways. You can like draw it out. You can use Legos. You can explain the different small pieces and like finding a way that connects with whoever you're talking to. You might have to go through a whole long list of like different examples and different ways of looking at it before you both arrive at like this place of shared understanding of the concept. So teaching definitely has helped me in the past to solidify core concepts. Yeah. Which is why doing this is so helpful. I'll be able to not that I'm teaching you, because I'm definitely learning myself, but kind kind of talking at the camera will give me that sense of like trying to explain things in my own words, which will help me learn even more. I'm going to take a sip of my hot chocolate right quick. It's pretty chilly in my apartment since I have like the sweater on and the like sheet up. That definitely helps, but having the hot chocolate is also just like so warming and nice. Okay, moving on. What to do when you're stuck. You will inevitably get stuck at some point in the curriculum, perhaps due to a concept that you're having difficulty understanding, or perhaps due to something not working correctly in a project. Whatever it is, use the following tools to get unstuck. Google. You can be certain someone else out there has encountered the same problem as you at some point. A quick Google search can often lead to a solution. Take a break, allow your diffuse learning state to work on the problem, or ask for help in the chat. Come prepared with your research. People will be more willing to help you when they can see you've already put in effort to figuring out the solution to your own problem. So that's a huge, I think that's a whole section of the foundations course is how to ask questions, and we'll get to that later. But yeah. Managing your study time. You will have more success with Odin by putting consistent time into it rather than working on it once a week. Building a habit of studying every day at a specific time with a specific goal will ensure you make consistent progress. Like I'm doing with y'all. We're gonna do it. It may take you longer than others to grasp concepts, or it may take you less time. This doesn't mean you're smarter or dumber than others. It means you've had different life experience that may or may not have prepared you for learning this stuff. Someone who grew up around an engineer may have some advantages over people who didn't, but it doesn't mean you can't learn those skills. The Odin Project isn't like college or university. It is self-paced and allows you to get a really solid grasp of concepts before moving on. In school, you're forced to keep up or you will fail. The difference here is that coming into Odin Project, you're not expected to have much knowledge. There are no prerequisites. We've had people successful coming through here who only knew how to check their email on computer. We've also seen success from computer science degree holders. Treating the Odin Project like a static timeline is understandable, but it is a sign of misplaced expectations. You simply don't know what you don't know. And that's okay. There are no due dates on things in the Odin Project, so you can spend the time to do it right and discuss the topics. Deadlines cause unneeded stress. Since the Odin Project is a free and open platform, you're not beholden to a deadline. Creating your own deadlines is a good way to rush concepts that should not be rushed. The course is very resource-based, meaning you will have to do research. My words! You'll have to do research to complete tasks and projects. There's no telling if you can find the article or post that helps you right away, quickly to meet your deadlines. But we bet you learned a ton along the way that you can use in the future. People that do this kind of research and strive to write better solutions tend to become better developers in the future. There's no knowing how long it could take you to learn how to query stuff to find your answers. There are no solid guidelines on that. If you're doing the Odin Project because you need a high-paying job right now, you're not going to become a solid developer within the framework you have set. Stress and anxiety do not help you learn. Relax and enjoy the ride. Long story short, don't worry, just go learn. Some common pitfalls to avoid. The following are pitfalls that beginners often encounter when learning to program. Try your best to avoid these. So procrastination. Procrastination will be your biggest enemy when trying to make progress. There's a solution, the Pomodoro method. You basically have 25 minutes and then a 5-minute break. There's this timer, tomato timer, online. It's linked here. You can also just type in tomato timer. I'm going to click on this so you can see what it looks like. But it'll have 4 of these 25 minutes work, 5-minute break sections, so about 2 hours, and then you take a longer break. And this is meant to like maximize your creativity and your productivity. There's the word that I was looking for. Maximize your productivity. So, I'm not going to start that because we're here together and we're kind of already being motivated and productive, but it is a good method to use if you're struggling, because then you have those 25 minutes where you're super focused, and if you get distracted, like your phone chimes, you get pulled away from what you're doing, you start the 25 minutes over and don't get a break until that 25 minutes is completed. And like, you can do a lot of things very well for 25 minutes. Like reading, after about 30 minutes, my attention starts to drift away. 25 minutes is a great way to just like keep it focused for that long. I know that I can do that. All right, moving on. Okay, not taking breaks is the next pitfall. So a lot of people will just like not take breaks. They'll be super about it, but then also get burnt out. If you're not taking breaks, then you're only staying in that focus mode that was mentioned earlier. You're not allowing any of that diffuse time, so it's like hindering your learning, but also using a ton of energy. I'm not reading this verbatim because at this point we're just talking about mostly concepts that I'm more familiar with, so I'm just, gonna talk through it. So the solution, they had the timer above already, a good method to use to time your breaks. And they have suggestions for what to do on your break. I think if you are working at a screen, doing something that looks away from the screen, so not going from your computer to being on your phone, but like having a book or having some sort of craft, or my dad used to work in a high-rise building, so every hour or so when I would visit him at work, we would like go and stand at the window and like try to read as far away as we could. It helps your eyesight, helps your brain, helps you sleep better at night, to be away from the screen for a little while. So speaking of digital distractions, these are things like email, Facebook, Instagram, who posted what, just all the notifications basically on your phone or that your browser could be popping up. They can be distracting, so turning off notifications, having an ad blocker for any of the pop-up ads, or those things are great. Physical distractions, this one's a little more difficult. I personally live with roommates. It's just kind of the nature of our economic climate right now that a lot of us are living with roommates. We don't have our own one-bedroom apartments because who can afford that? So sometimes there are just noises and things. That's why I'm wearing my headset though. I can have like a white noise playing that kind of drowns out some of the extemporaneous noise. I have like the lights a little lower so that I can focus more clearly. Just having like some place that you can really curate. But again, that's not always available to everyone just because everyone's situation is different. All right, we're on to the next one. Rabbit holes. I love a good rabbit hole. I'm going to read this one because I don't know what they're trying to say about it. Because we cover so much material on the Odin Project and link so many high-quality courses and tools, it's easy for students to get pulled into rabbit holes by spending time trying to learn all there is to know about a subject that they aren't ready for or won't be able to benefit from. We have put a lot of effort into structuring this curriculum so that all of the important things that you need to know about web development are covered exactly when you need to know them. So the solution is just sticking to the path laid out as much as possible and try to limit the time spent going down rabbit holes. Comparing yourself to others is another, I would say that's a mistake in any situation. Like obviously you want to, I personally really enjoy living up to the expectations of others, and will sometimes use my peers or my coworkers as kind of a gauge of if I'm accomplishing that or not. But this is not a work environment. Like, we're just trying to learn for ourselves. So comparing ourselves to how others have learned isn't going to help us at all. We already know just a little bit more than we knew yesterday. Not much because we haven't really done anything yet, but that'll change soon. Alright. These are additional resources, but I'm going to skip them. I know, I said I would not, but I'm going to. I'm going to make sure that I updated the stream information. I'm worried that I am misrepresenting this as hello. I just want to make sure that this is the okay. Edit stream info. I'm sorry that I'm being so unprofessional right now. Okay, we did it. Almost. Okay, we did it. Yay. We're back. Lesson completed. Next lesson. Asking for help. So this one gets into how to use like forums and the Discord and get help around when we're stuck. So along the journey, you'll definitely need to ask questions in an online coding community like ours, or in conversations with colleagues. While asking questions may seem rather simple, in a programming environment, it is essential to ask well-formed questions. They mentioned the Discord chat and then Stack Overflow, which is a great resource that we'll also get into later. This section contains a general overview of topics. Oh, I didn't need to read that. Alright, tips for getting the best help possible. Provide your code in the surrounding context. You can ask theoretical vague questions, but you're going to get theoretical vague answers that probably won't help you and cause frustration on both ends, as you and the person helping you dance around the real issue. The only time code doesn't need to be provided is if you're asking a purely conceptual question outside of a specific code or code snippet. Additionally, provide as much context as is necessary, and zero in on the specific problem, such as pointing people to a specific function or a line number in your code so people can give you the most relevant answer and quickly assist you. Ask the problem at hand, not the solution itself. A lot of learners will ask about like an approach to a given task or assignment. So how do I complete step 5 rock, paper, scissors? Keep in mind that you're actually supposed to figure out how to solve the assignment yourself, and figuring out an approach is essential to your journey. So a better question would look like, hey, I'm trying to return a string that displays the winner in this rock, paper, scissors, but I'm getting a syntax error on line 12. How do I fix this? And then you would show your code afterwards. And sharing your attempt, people know you've tried and won't suggest things that might not have worked for you. It also allows them to debug your current iteration of code rather than sending you down a path that has you start all over again when you might have been very close to a solution. Now, if you're completely stuck and don't know where to start, it's completely fine to let people know you're stuck. Asking where you can start and what you can research to get on the right track empowers you to be able to resolve issues largely on your own in the future. It might even empower you to help others with the same issue later on. It is also recommended that you share your pseudocode so people can nudge you in the right direction or correct misunderstandings you may have. If people ask for more context, don't take it to heart. People who volunteer are here to help, but a question you feel is coherent and obvious probably isn't if you're being asked for more context. While something may seem obvious to a beginner, it's sometimes nowhere near obvious to an expert. An expert knows about many, many more solutions that could cause situations that could cause an issue someone is experiencing, and would want to refrain from sending a learner down the wrong path. People take time out of their day to help, so make it as easy as possible for them to help you. There's probably a good reason they need more information, so trust their judgment and experience. So if people ask for more context, help them help you. So there's this article by, I'm going to close out the tabs from the last article. So this article, the XY problem, Stack Overflow, and then Help Vampires. I'll just talk about Help Vampires. This article it's fairly long, which is why I'm not reading it. I have read it, but like I said, it's fairly long. So it's basically people, like if you have a question or are struggling with finding a solution to a given problem, just immediately going and asking without looking to see if the question has already been asked or trying to do the research on your own. And so best practice is to actually search for the answer, to search for resources that can guide you to an answer before going in and like posting a new question, because a lot of people who have worked through the Odin project, my guess is that most of the questions have been asked already, and a lot of people have also learned how to code, so most of the questions that you could have would already have been asked and answered, potentially very eloquently as well. Oh yeah! Support rail strikes! Yes! Yes, support rail strikes. Yes. I need to look. Okie dokie. Okay. Okay, so for the knowledge check section, we're going to name one thing your question should always include. So your question should always include like the actual problem that you're having, and specifically you should also include either your code if you've already approached the problem and tried to troubleshoot and debug, or your pseudocode for how you believe that it should be built out. The XY problem, we didn't go into this, but it's really well explained by this article. So asking a question on how to get to a given objective instead of asking a question about a potential solution. So if you are, I think the examples do a really good job here. So example 1, where they want the type of file extension, and they had created some code to pull just the last 3 characters in a file name to give like .docs or .exe, but what they are actually looking for is just the file extension name. So they had asked, like, how do I pull the last 3 characters, when in actuality they wanted to pull the file extension. So the clarification that the forum user gave was there's no guarantee that the file will have a 3-letter extension, so here's a way to grab the actual like file extension instead. So that was the XY problem. And then we've already talked about Help Vampire, just like not going and researching your own questions before bringing them forward. and like generally asking for too much help from the community. Just gonna look. Cool. So that one is completed. We're moving on to the next next article. So this one is joining the Odin community. They're saying things like join us on Facebook, follow us on Twitter, catch up on Instagram. The community is going to be really great for when we're like encountering issues, because a lot of people asking questions will have happened in the Discord. So yeah, joining the Discord is going to be good, asking for help. So as most of the projects are designed to push you to your limit, please remember that there is always a community to turn to. You don't need to know how to solve every problem straight away, but you do need to have a general idea of where you're going. This becomes really important when asking your questions, because sometimes the problem is your approach and not your code. If you're feeling stuck, it's a good time to pause and take a breather. Break the problem down into little pieces and then decide what is really holding you back. We call this technique rubber duck debugging. I'm going to exit these. Cool. We'll give that a look over. You should also do a Google search to find relevant information for your problems. Read how to use Google to solve your programming questions. We'll click on that one. Is this just the Google homepage? They legit just linked the Google homepage. That's great. If these methods don't yield a solution for you, then it's time to reach out to the Odin community for help. The first thing to keep in mind is don't ask to ask. This is a simple idea with a pretty catchy motto. It can help you get answers to your questions much faster, and it will make it easier for others to feel comfortable offering you help. When asking your question, please remember to include the following. What do you think the problem is? What exactly do you want to happen? What is actually happening? And then how did you get there? What have you tried so far? If you can't pinpoint a problem, you can share a screenshot. This is especially useful for showing the output of commands in the command line. In Discord, drag and drop your screenshot image file into the chat box to upload, or simply use print screen and paste keyboard shortcuts. If you don't know how to take a screenshot on your computer, this is a good time to ask Google. So for Windows computer, there's a button that says PRT SC, PRT space SC. You can hit that and it'll take a screenshot of your computer, and then you can paste it, so Control V, into either a Word document or probably into the chat. On a Mac, it is Control Shift 4, or Command Shift 4. And that allows you to drag, and then it'll create a little image file that just pops down into the bottom right corner of your desktop. But also Googling that is a great way to learn it as well. I'm gonna take another sip of my hot chocolate. Screenshots are great for showing the output of commands or error messages in the command line. Screenshots are also great for showing the output from your code, such as how the output looks visually on a web page or console outputs in the browser. However, you should always include the corresponding files containing the error, even if it's a short amount of code. Providing in the Discord server in the proper format along with a screenshot of the output is helpful to those debugging it rather than just a screenshot. When you do share a screenshot of the output or how it looks visually, make sure to push your project to GitHub or put your corresponding code in a replit so others can come through and debug the code. The screenshot of the output and the correlating code that can recreate the problem will help make it easier to understand the problem for people helping you. You'll learn about GitHub very soon. There's also the Discord search feature. In case no one's around, you can search for specific keywords or error messages to see if someone has had a similar issue before and how they solved it. And so that's something that I might actually do first before messaging the community, just seeing if the question's already been asked, because likely it has been. Formatting your questions. Asking your questions in a readable format helps everyone debug them better. Here are some ways to go about that. If you're having trouble on the command line, make sure to include both your input and the error message that you're getting. In the chat rooms, code can be displayed differently from normal normal sentences by using backticks. So that's the opposite way of a apostrophe or quotation mark. So your code would look like this. For a single line of code, single backticks, and then for multiple lines of code, you would do 3 backticks. So kind of similar to how you demarcate comments in code, depending on what syntax you're using. You can also use code highlighting to add color. So you would specify your language that you're using. So they use JavaScript in this instance. So 3 backticks, JavaScript, and then your lines of code, and it would make it dynamic and colorful the way that it would appear in the command line. Now, have fun with GIFs. Type \Giphy. You can find more information on chat commands with exclamation point help. Just some useful chat features. Then how to help others solve code problems. Not only is it important to know how to ask effective questions, it's also important to know how to help others effectively. So this goes back to that whole teaching is a good way of learning. Because when you are teaching someone, you have to have a full grasp of what's going on. So instead of answering the question, guide them to an answer. So unless it's a simple typo or syntax error, it's more beneficial to guide them to find their own answer. This will teach good debugging skills and will increase their ability to solve future problems. So start by asking, what have you already tried? What do you expect this function to do? And what do you think that error means? Which is sometimes the worst thing to hear. You're like trying really hard. You've searched for an answer, you couldn't find it, you know that the answer is like super obvious and you're just missing it, and then you go to ask your question and someone's like, well, what do you think the error means? I'm like, oh, I understand why they put it, but if I'm asking a question, then I've already tried all of the things that I know. Help only when you are certain of the answer. If you're not 100% certain of the answer, you may end up doing more harm than good, so let someone else answer it if you're not like fully certain. Don't worry about how long someone has to wait for an answer. The right answer is worth the wait so that you don't go down the wrong rabbit hole. Help only when no one else is currently helping. If someone's already on it, you don't need to jump in. And then if you don't have time to help, let somebody else, because you don't want to start and then someone else see that you're starting and back off, and then you don't have the time to like actually help them. And then adjust your expectations to their level. So if you're in the Odin community, it's likely another learner, and we're all coming to this with different like levels of experience, so just taking that at face value. And then if the question seems ambiguous, you can ask for more clarity, or then and then politely link them to the command bot, the bot command questions, which links the How to Be Great at Asking Code Questions article, which we previously read. You can ask for live code. So this goes back to the guidelines that they had given already of how to upload a question, just including your code so that people can interact with it. And then don't answer Googleable questions. Learning how to research is very important, so if it's something that they can Google, politely ask them to search for it on their own, or just use the bot command with the search term. And then don't answer questions covered in the curriculum. If you know it's in the curriculum, just ask them where they are in the curriculum. If they've not reached that portion of the curriculum, you can let them know they'll learn it in a future lesson. And if they've already been through that portion, you can re-guide them back to it, just letting them know that the answer is in there and that they can spend a little more time with that material. Answer the question before pointing out other problems. So if you notice something in their code that is outstanding, outstanding is in like it stands out. You can resolve their question first before pointing out other problems. And then encourage students to use a debugger. It's common for them not to understand the importance of using a debugger to look at the values of their variables at different points in their program. When students are getting unexpected values, politely encourage them to use a debugger with our bot command debug. Watch for students that need to take a step back. It's common for students to focus too hard on a problem and not be able to see clearly. When this situation arises, politely encourage them to step back from the problem and take a break. Oftentimes, stepping away from a problem will give them the bigger picture and let them see how to solve it. Watch for students who are in over their head. It's common for students to skip a lesson, project, or think that they know more than they actually do. When this situation arises, politely encourage them to go back and reread a section of curriculum for more understanding. Admit when a problem goes beyond your current knowledge. So this goes back to if you don't know the answer 100%, then don't go for it. So if you find that your knowledge is not adequate for solving the particular problem, then just admit that you're unsure and someone else will help. And then be patient. And then if you're getting frustrated, it's always best to just hop out of the conversation. So here are some assignments. So GitHub account. So I've already created a GitHub account. If you haven't seen GitHub before, this is the login page. Oh, this is the account creation page. But I have done this part already. Here's the Discord server. Which I have just joined. Alright. You cannot currently see my screen. Well, you can see this screen, but not the Discord. But I have just joined the Discord. I slid into the chat. Pop in and say hello. We've created an introductions room, which is a great way to introduce yourself. So link your GitHub and Discord. Sorry, had a neck pop. You can go to Discord settings, connections, and then click the GitHub icon to link Discord and GitHub. In the new tab that opens, click Allow Access. Alright. And then here are some guidelines before we dive in. So ping at user with purpose. Only ping others when it's necessary. Don't bomb the chat. Don't exclude anyone. Don't disappear right after asking for help. Remember the human. There's a human behind every username. If you wouldn't say it out loud, don't say it in the chat. Don't type it. And then read the FAQs. So I'm going to call this one completed. I am going to look at some of these. So cool. Replit, I've never really interacted with. Ooh, well, I like that. I like when websites are like that, where you scroll and instead of like going down a larger page, it like does something different, goes sideways or pulls you in like this one does. Cool. Good to know that this exists. I think this was basically the whole point of this, was to know that it exists, but this is a great way to share code. Don't ask to ask. Okay, so in online chat rooms, people will pop in and say something like, any Java experts around? So this is bad form for several reasons. What the person is actually asking here is, any Java experts around who are willing to commit into looking into my problem, whatever that may turn out to be, even if it's not related to Java, or if someone who doesn't know anything about Java could actually answer my question. So this just goes to ask your question, formulate the question in a way that helps people help you. That's really funny. This is how to use Google to solve your programming questions. Oh, this person has started a YouTube channel. I wonder if they're still up. I released a video. Cool. Rubber duck debugging. In software engineering, rubber duck debugging is a method of debugging code by articulating a problem in spoken or written natural language. The name is in reference to a story in the book The Pragmatic Programmer, in which a programmer would carry around a rubber duck and debug their code by forcing themselves to explain it line by line to the duck. Many other terms exist for this technique, often including different, usually inanimate objects, or pets, such as a cat or a dog. Many programmers have had the experience of explaining a problem to someone else, possibly even to someone who knows nothing about programming, and then hitting upon the solution in the process of explaining the problem. In describing what the code is supposed to do and observing what it actually does, any incongruity between these two become apparent. More generally, teaching a subject forces its evaluation from different perspectives and can provide a deeper understanding. By using an inanimate object, the programmer can try to accomplish this without having to interrupt anyone else. This approach has been taught in computer science and software engineering courses. I like that a lot. I would agree that that's very helpful. Next lesson. So computer bases. This is where I think we'll start to get some more learning. So far it's just been an introduction, but I think we're going to start into the meat of it. We're into the thick of it. I'm going to have another drink of my hot chocolate. Okay. So, needless to say, whilst learning to code, you'll be spending most of your time on a computer. Hence, understanding how to work with your computer is crucial. In this lesson, we'll introduce a resource which will quickly get you up to speed with some computer basics. This section contains a general overview of topics that you will learn in this lesson. So, computer software and hardware, how to take screenshots, and then the importance of strong passwords. The Goodwill Community Foundation, GCF, resources are excellent to get you acquainted with the basics. They have accompanying videos and illustrations that are easy to read. The following readings should be sufficient, although you are welcome to explore more of their resources. So we got 6 of them. And then we'll have a knowledge check after the fact. So, let's dive into it. What is a computer? A computer is an electronic device that manipulates information or data. It has the ability to store, retrieve, and process data. You may already know that. You can use a computer to type documents, send email, play games, and browse the web. You can also use it to edit or create spreadsheets, presentations, and videos. There's the video below. Yeah.
Computers are all around us. From laptop computers to smartphones to smartwatches.
Oh.
They're changing the way.
Y'all might not be able to hear, huh? Hi! Yes, nutrition is important to learning. That is true. Sound is fine? Okay. I'm doing well. Welcome. Okay, I'm gonna go back to the video. Okay.
Computers are all around us. From laptop computers to smartphones to smartwatches. They're changing the way that we live our lives. But have you ever asked yourself, what exactly is a computer? A computer is an electronic device that manipulates information or data. The computer sees data as ones and zeros, but it knows how to combine them into much more complex things, such as a photo, movie, website, game, and much more. Computers use a combination of hardware and software. Hardware is any physical part of the computer, which includes the internal components and the external parts like the monitor and keyboard. Software is any set of instructions that tells the hardware what to do, such as a web browser, media player, or word processor. When most people say computer, they're talking about a personal computer. This can be a desktop computer or a laptop, which has basically the same capabilities, but in a more portable package. Personal computers come in a few different styles. The most common type uses the Windows operating system. Macs or Macintosh computers feature the Mac OS operating system, while Chromebooks run on Chrome OS. Smartphones and other mobile devices mostly use the iOS or Android operating systems. We'll talk more about operating systems in a later video. Computers come in many other shapes and sizes. TVs, game consoles, and even appliances like refrigerators can have built-in computers, although they may not do everything a desktop or a laptop can. There's another type of computer that plays an important role in our lives: servers. A server sends information to other computers on a network. In fact, every time you use the internet, web servers deliver the web pages that you want to see to your computer. Servers are also used in many offices to store and share files. As you can see, there are many types of computers out there, and each one plays a part in our modern world.
Okay, I'm gonna pause it there. Cool. I like their little animations, but I think I need to watch videos on higher speed. I get antsy. Cool. Pretty basic so far. Hardware versus software. So hardware is physical structure. It's physicality, how the computer functions inside, and then software is a set of instructions that tell the hardware what to do. So everything you do on your computers, hardware and software, yes, Yes, these things make sense. I might skip over a bunch of this. Different types of computers. They're like PCs that we interact with, personal computers, but then there's also calculators, which were some of the first computers, and then ATMs, refrigerators, toasters, anything that can play Doom. So desktop computers, laptops, tablets. Servers are cool. So if I'm scrolling through this and you don't already know this information, then I would encourage you to go ahead and review this by yourself. But I'm gonna just pass through over it. This is not for school. No, I'm just trying to learn for my own sake. Yep. Alright. PC versus Mac. There were those like old videos that had the Mac versus PC. I think they were actually Apple commercials. They had like the white background. Those are pretty funny. Alright, operating system, which is an OS. Hopefully this one will actually mention Linux. Yes, I do want to get into programming. Yeah. What's an OS? It's the most important software. It manages memory and processes, as well as all of its software and hardware. Without an operating system, computer can't do anything. I might skip the video this time because it seemed like the video was summarized in the later meat of the article, so we're just going to read what it says instead of watching the video, even though the animations are very cute. So, the OS manages all the software and hardware on the computer. And they all need to access your computer's CPU, memory, and storage. The OS coordinates all of this to make sure that each program gets what it needs. Types of OS. There we go. There's Linux. Operating systems are preloaded on computers you buy. Most people use the OS that comes with a computer, but it is possible to upgrade or change the OS. The three most common are Microsoft Windows, Mac OS, and then Linux. Modern operating systems use a graphical user interface. I like that it's pronounced GUI. That makes me very happy. A GUI lets you use your mouse to click on icons, buttons, and menus. Everything is clearly displayed on the screen using a combination of graphics and text. Each OS has a different look and feel, so if you switch to a different operating system, it may feel unfamiliar at first, but they are designed to be easy to use, and most of the basic principles are the same. Yeah, they haven't mentioned much programming yet. It's all just introduction so far. Okay. I might skip actually most of this and check what the knowledge check asks. So is Windows an operating system or an application? It's an OS. What's the difference between open source and closed source software? Open source has many contributors. It's more like public, sort of. And then closed source is more private or proprietary. And then what are some use cases of a screenshot? It's anytime that you want to show something that is happening on your desktop to someone else who may not have access, like to physically look at your screen. And then an example of a strong and a weak password. A weak password would be like your cat's name with your birthday. No special characters, not a lot of like differentiation. And then a strong password would be like the word password. I am joking. Please use strong passwords. All right. We're marking that one as complete and then moving on. Then how does the web work? This one I'm actually interested in. Oh, cool. You're a game programmer. Super cool. I had downloaded Visual Studio when I was in college to try to learn some game programming, but I got way too busy and ended up dropping it. All right. Okay, before you can understand how to program the web, you need to understand how it works. So this lesson will describe what the internet is, describe what packets are and how they transfer data, understand the differences between a web page, server, browser, and search engine, briefly describe what client versus server, then IP addresses and DNS servers. Okay, so we have our little assignment here. I'm just going to check the knowledge. Okay, I do actually want to read some of these articles. There's so many. Okay. I'm gonna turn the speed way up on this one because, yeah.
Single day, we upload 4 million hours of video to YouTube. We send 682 million tweets. We post over 67 million Instagram pictures. 4.4 billion of us use the internet, and collectively we create 2.5 exabytes. That's 2.5 million terabytes, or 2.5 quintillion bytes of data every single day.
And a significant proportion of all of that data, searches, news, messaging, social media, video streaming, goes through here.
This is Telehouse
So
North,
loud.
one of the most important parts of the internet backbone. It's one of 4 buildings here in London full of computers, cables, cooling equipment, and sheer geekery.
The internet was built on many
Geekery.
ideas, but the big one happens exactly 50 years ago this week.
The warp had origins in 1969 when the American Defense Department, specifically the Defense Advanced Research Projects Agency, decided that it needed a network to connect about a dozen university computer systems together in order to promote sharing of information and acceleration of research in artificial intelligence. And so they promoted the design and development of a packet switch network, which they called ARPANET.
On October the 29th, 1969, at 10:30 in the evening, the first message was sent over ARPANET.
I was
A computer
wondering what
at
time.
the University of California in Los Angeles sent a word to Stanford Research Institute in San Francisco. The word was login, although the system crashed before they got to the G.
No.
Nevertheless, those 2 nodes became hundreds and then thousands and then millions of connections. A global network of networks now consists of over 1.2 million kilometers of submarine cables, sometimes laid as deep as Mount Everest is high. These connect massive server buildings, and immeasurably more smaller cables connect those to individual computers. An interconnected network that Vint Cerf and Robert Kahn named the Internet.
It's important to understand that the internet is not the World Wide Web. The web is a great invention. It's the way that data, web pages, services, and documents are arranged, accessed, and addressed. But all of that sits on top of the hardware that is the internet, which allows many, many networks to talk to each other in a really clever way.
So, say you want to watch a cute video of a cat. Well, your request to see the video shoots out of your device along regional networks and at some point races through Telehouse North and off across the globe to where the video is stored. And this is where it gets really clever. See, sending the whole video in one go down one route will likely mean that it will get stuck in traffic and take ages. So the video is torn apart, broken up, split into little packets, and each one makes its own way back down different routes.
This video is so British. I love the exploding cat is so much. Okay.
And when they start arriving back at your device, they're juggled into the right order. And once enough of the start of the video has arrived, there's your cat, as cute as you wanted. This is how information
So British.
spreads across the world. But unfortunately, it's not always the right information.
We have a tough problem ahead of us, which is to try to help people distinguish good quality information from bad quality information.
One of the big problems seems to be that these days we're all locked in our own echo chambers. The information we hear comes from people that we've chosen to
Okay.
listen to. So as well.
Okay, cool. I'm gonna move on from that one. Okay, how does the internet work? All right. What is this? Cool. The internet is the backbone of the web, the technical infrastructure that makes the web possible. At its most basic, it is a large network of computers that all communicate with each other. The history of the internet is obscure, but it began in the 1960s. Army funded, and then evolved into public infrastructure in the 1960s. And they have these videos. Is this the same? I'm just curious. Is this the same video that we just watched? No, it's further linked. Cool. And then this might be the one we just watched.
How does the internet work?
No, cool. That's a different one. All right, diving deeper. When two computers need to communicate, you have to link them either physically, usually with an Ethernet cable, or wirelessly with Wi-Fi or Bluetooth systems. All modern computers can sustain any of those connections. And then this network is not limited to two computers. You can connect as many as you wish. You would need a lot of cables to connect a lot of computers. To solve this, each computer on a network is connected to a tiny computer called a router. It only has one job, and that's to signal between all the different computers. All right. The diagram, I believe, says it very well. And then a network of networks. So far, so good. But what about connecting hundreds, thousands, billions of computers? Of course, a single router can't scale that far. But if you read very carefully, we said that a router is a computer like any other, so we could connect routers. And connecting computers to routers and routers to routers, we're able to scale infinitely. A dangerous word. Infinite. Such a network comes very close to what we call the internet, but we're missing something. We build that network for our own purpose. There are other networks out there, your friends, your neighbors, anyone can have their own network of computers. But it's not really possible to set cables up between your house and the rest of the world, so how can you handle this? Well, there are already cables linked to your house, for example, electrical power and telephone. The telephone infrastructure already connects your house with anyone in the world, so it's the perfect wire we need. To connect our network to telephone infrastructure, we need a special piece of equipment called modem. The modem turns information from our network into information manageable by telephone infrastructure and vice versa. So we connect to the telephone infrastructure. The next step is to send the messages from our network to the network we want to reach. To do that, we connect our network to an internet service provider, ISP. An ISP is a company that manages some special routers that are all linked together and can also access other ISP's routers. So the message from our network is carried through the network of ISP networks to the destination network. The internet consists of this whole infrastructure of networks. Finding computers. If you want to send a message to a computer, you have to specify which one. Thus, any computer linked to a network has a unique address that identifies it, called an IP address, where IP stands for Internet Protocol. It's an address made of a series of 4 numbers separated by dots, like this, for example. That's perfectly fine for computers, but we human beings have a hard time remembering that sort of address. To make it easier, we can alias an IP address with a human-readable name called a domain name. For example, Google is the domain name on top of the IP address listed. So using the domain name is the easiest way for us to reach a computer over the internet. Yeah, it is a little old, but it's similar knowledge though. What field am I interested in? I'm still figuring that out. I'm more so just seeing this as like a opportunity to learn something new, and pretty excited about it. So the more I learn, the more that I'll get a grasp on what I actually want to do. But I would love to just basically learn how to build my own apps, and then how to like how programs are structured and algorithms and the various things. And I do agree that game dev, it has appealed to me in the past, and there have been some games that I have like thought about building out, have even like written down some ideas about, but the industry seems a little daunting, to be honest. Seems oh, sweet, thank you. Yeah. That said, all dev industry seems kind of daunting though. Like breaking into any sort of software or like engineering seems daunting. Intranets are private networks. Extranets are open to all or part of a private network to allow sharing and collaboration. Oh yeah, so this is a good example of that. Cool. I'm going to exit out of that one.
This is the internet.
Cool.
The internet is a wire, actually buried in the ground. It might be fiber optics, copper, or occasionally beamed to satellites or through cell phone networks, but the internet is simply a wire. The internet is useful because two computers connected directly to this wire can communicate. A server is a special computer connected directly to the internet, and web pages are files on that server's hard drive. Every server has a unique Internet Protocol address, or IP address. Just like a postal address, IP addresses help computers find each other. But since 72.14.205.100 doesn't exactly roll off the tongue, we also give them names like Google.com, Facebook.com, or SecurityCatalyst.com. So this is how it works. Your computer at home is not a server, because it's not connected directly to the internet. Computers you and I use every day are called clients, because they're connected indirectly to the internet through an internet service provider. Here, we'll pretend that this is my home laptop, and I'm using DSL. Now let's pretend that I want to visit AOL.com, which is coincidentally both a server and an ISP. I hop onto my laptop with DSL, go through my ISP, onto the internet, and look at AOL.com. My computer connects with AOL.com, and I can look at its web pages. Now, let's say that I want to send an email to Aunt Ruth.
We thought the article was old.
And I've got a Gmail account. I log on to gmail.com and compose a message to Aunt Ruth's email address, auntruth@aol.com. Once I click send, gmail.com sends the email to
understand.
AOL.com. The next day,
I understand this, so I'm gonna exit out of that one. Wow. These little videos are amazing. They're reminding me of like employee onboarding or something. Okay, difference between web page, website, web server, and search engine. So, as with any area of knowledge, web comes with jargon. I do not feel overwhelmed. So, web page is a document which can be displayed in a browser. They're called pages. A website is a collection of pages, so we're currently looking at a page within the developer.mozilla website. A web server hosts a website on the internet, and then a search engine helps you search for web pages. Some of these I've not heard of, like DuckDuckGo. For a little while I was using Ask Jeeves, like a really, really long time ago, like in 2003, but I liked that it had the little guy with he was like, ask me anything. That's my impersonation of Ask Jeeves. We'll look at a simple analogy, a public library. So find a search index and look for the title of the book, make a note of the catalog number of the book, go to the particular section containing that book, find the catalog number, and get the book. Compared to a web server, you would use, okay, I'm just going to read it. It has several sections, which is similar to web server hosting multiple websites. The different sections in the library are like websites. Each section is like a unique website. 2 sections do not contain the same books. Cool. And then the search index is the search engine. All makes sense. And going deeper, web page is a document displayable by a browser. They're written in HTML. A web page can be embedded a variety of different types of resources like style, information, scripts, and media. So it has a unique address up at the top. We know these things already. Then a website. I'm glad that they listed their own. That's great. It's the example that I used as well. Then a web server. We have talked about all of this before, so I'm going to skip it. Okay. Another video, here we go.
The most important program on your computer is your web browser, and yet most people aren't sure which web browser they're using or what a web browser even is. Let me try to explain by first telling you what a web browser is not. A web browser is different from Windows or Mac, which are systems that allow you to manage files and programs. And it's different from a search engine, which is a website that is used to search the internet. Instead, a web browser is a program on your computer that allows you to visit websites. You get to your web browser by clicking on its icon. From there, you enter web addresses, and the web browser displays the web pages for you. The web browser is the most important piece of software on your computer because every web page runs through it. So a faster web browser means that you'll save time on every web page you open. Installing a new web browser is free and only takes minutes. So take a moment to choose a web browser that you like best today.
Okay. Very insightful. Yes, I am using Chrome. Cool. Alright. Additional resources. This section contains helpful links to other content. So there's Security Now's podcast, How the Web Works series, which is cool. I like podcasts. I'm not going to listen to it on here. A Packet's Journey. And then there's this book, which I will open and then see if they have it at the library. If you're in for a bit more reading, you can check out Intro to HTTP. Then fiber optics. Cool. And then some advice on reading. We recommend that you only read the immediate links in our curriculum. If you always go deeper on any subject, you can overload yourself. So I'm actually not going to check. Oh, cute. They actually just have this on. That's nice. I like that. Okay, we're going to mark this lesson as complete. We have officially reached the point where I had gotten to before starting this streaming series. So, new territory. Next lesson. I'm going to see how far in the foundations course we have gotten. Okay, So we are just still starting the prerequisites. Cool. Installation overview. Still have a ways to go. Maybe that'll be my goal for today, to finish the prerequisites, if I can stop tripping over my words. First step for building any website is having the right tools. Many online development courses have the in-browser code editors, so like Codecademy has that whole little section set up and then has the like instructions off to the side, so you can do it all in browser. You'll use some of these sandboxes through the early stages of Odin projects since they're great for getting quickly started. However, the best way to set yourself up is to get a real development environment. And we won't lie to you, installing packages, editors, and entire operating systems can be very frustrating. Can attest. However, having the experience of setting up a development environment to run code is an invaluable real-world skill you'll carry with you for the rest of your career. The installation plan. In the following sections, we'll go over the steps for setting up your environment. There is no need to install anything in this lesson. This is informative. These sections are the most important steps in the entire curriculum. Please take time to double check what you're typing, or you may cause more headache for yourself down the road. Okay. In the next few lessons, we'll talk through these installation steps together. Installing a supported operating system. Is this just, it's the Wikipedia page for what an operating system is. Nice. Installing a Google Chrome web browser, which I'm already operating in. Installing a code editor. Creating an SSH key, personal password, that will identify you to GitHub, Heroku, and other sites you'll be using. And then at the end of the lesson, you'll be up and running with many tools that you need to write and run code. It seems like a lot of steps. We'll get through it as painlessly as possible together. If anything goes wrong, use these steps. Examine the terminal output for the actual error, Google, and then ask for help. For Chromebook users, your OS choice has effectively been made for you. However, if your device supports the Linux beta, there are instructions in the next lesson on how to set up your device. So OS options, if you're using a Mac, you're in great shape. The Odin project instructions assume a Unix-based system. By installing just a few programs, you'll be up and running with your education in no time. And then Linux is a free and open source operating system that works well with all programming languages. Most development tools are written to work natively with Linux. Your tools will likely be updated more often. You'll have more information available for troubleshooting, and it's just plain better to run on Linux. We'll be using Ubuntu, one of the most popular and user-friendly distributions available, or the lighter weight alternative, Xubuntu. If you don't use a Mac, we recommend that you use Linux. It's that simple. Windows is not natively supported by the Odin project or on our Discord server. However, if you're currently using Windows, you can either run a virtual machine or dual boot to keep your Windows install while creating your development environment in Linux. This is what I had previously done when I was dabbling. That took a while to set that up. A virtual machine is an emulation of a computer that runs within your existing OS. It allows you to use another operating system inside of a program on your current operating system, running Linux inside of Windows. Virtual machines are as simple to install as any other program and are risk-free. If you don't like Linux, you can easily remove the virtual machine. Virtual machines are a great way for new developers to get started quickly. Watch this video on VMs to achieve an overview of how they work. Dual booting means installing two operating systems on your computer, which can give you the options to boot either Linux or Windex. Not Windex. Windows. That would be kind of funny though. Linux or Windows when your computer first starts up. My computer's name is Matilda, but if I end up downloading Linux on her, I might change, her middle name might now be Windex. Don't use Ubuntu. Okay, good to know. Yeah, I like Chromebook. Fedora. I will look into Fedora. Cool. Nobara. Cool. I'm gonna get my little sticky note. Write these things down. We got Fedora. I do some gaming, yeah. I don't do a lot, but I have streamed like Control before. I was pretty into Control, and then I like Stardew, and yeah, Control's amazing. Like when I opened it the first time, I like had these chills. It was just it's such a beautiful game, and yeah, I'm not very good at it. Yeah, Nobara, thank you. That's the one that I was. Cool. Right. Dual booting. You can have 2 operating systems. You can boot either. Yes, it can be a flash drive or clicking some buttons. Concerned about installing a new OS? If you don't have an Apple computer, you're likely using Windows. Don't worry. The options above don't mean you need to get rid of Windows. Linux will gladly share the hard drive with Windows. We know you've probably learned a lot of tips and tricks for your favorite OS and don't want to lose everything you have on your computer. However, most OSs are developed with non-technical folks in mind, so they hide or make it difficult to use many of the languages and frameworks we'll need to install. Having to work around these difficulties causes many new developers to give up before they've even started their journey to full stack nirvana. No! It's just the setup! Modifying or dual booting a computer to work with the tools you'll need will make it much easier to start programming. Can help create a distraction-free environment and will look good on your resume. Take a deep breath and let's look at your options. Still not convinced, so Linux is tested. We've tested our directions with macOS. We did the research, so you can get tools installed with as few issues as possible. Yeah, spending time pebble wrestling with an OS is not so good. Community support, the tools make it easier to, yes, I understand. I agree that Linux is probably the way to go for me. Many learners come to our Discord channel to ask if the directions on this page need to be followed. The moderators wrote everything about the installation plan. That's really funny. Those supporting learners on our Discord server agree with the guidance on this page and will make the same recommendations we've made here. That's so funny to me. That's like when you're a kid and like your mom says you can't hang out with your friend because it's too late, and you're like, Dad, Mom asked me if it was okay with you for me to go and hang out. Sorry, that's just what it brought to mind. Before we can continue, we must stress one detail of importance. We can only support what is provided within the scope of our curriculum. We do not support native Windows or any version of Windows Subsystem for Linux, WSL, as a development environment. Using Windows and WSL has been discussed many times and is not feasible for us to do at this time. Do not ask us to support Windows. Do not bring it up in the Discord. We are constantly evaluating our curriculum to keep the content as fresh and accessible as possible. Windows has not proven to be a path of low resistance. With that out of the way, we need to set up an appropriate dev environment. Okay, mark complete. Sorry, that lesson was very sassy and it just made me very happy. Second hard drive, cool. Yeah, Linux is cool too. It's got the little penguin. Alright, you're already using macOS Ubuntu as your operating system and have Google installed, you can skip it. So I might end here, and then I'm assuming there'll be some downloads, and I don't want to just waste people's time watching me wait through a download, so I will do some of this and then come back in the next one and kind of just walk through what I did downloading, which I ended up doing. And then, yeah, so I will end it here. Just gonna read through the chat. I'm excited about Linux though. I'm excited about it. I've wanted to work in Linux for a while now. Oh, you're so sweet. Okay, let me see if I have... where is... I will get a Discord set up for the next time. I'll put it in my about. Yeah. Oh, that's cool. Cool. Alright, well, I am gonna head out though. Thank you for stopping by and your contributions to the chat. And yeah, so thank you.